So this is the second question I have, and this one has the answer I found like somewhere on the internet. This is the question which already have the same kind of difficulty level. So there are two boats approaching the marina. The velocity of one boat relative to the boat two is given. So that means the one respect to two is given, right? And they're asking that they give us like the 47 degree east of north. If the boat one has a velocity that is 0.775 meter due north, what is the velocity and the magnitude, including the magnitude and direction of the boat two? So for this question, again, let's draw the components and the directions. So none of them is it going due east, right? So that means the boat one has a velocity 0.775 is due north. So this direction is the north, and that direction has a velocity which is 0.775, and that is due north, which is like y-axis component. And for the second velocity is 1 relative to 2, so this is like 1 relative to 2, so that is a 47 degree east of north. So east of north is like somewhere right here. So I will say this is the direction, like 47 degree, and that is the direction of v12, like the boat 1 relative to 2, that is given as 2.15 meter per second. Okay, so now the question is we're looking for the true velocity of boat 2. For solving that question, first of all, let's resolve the component of v12. So v12 vector will have two components. So the one is along the y component, which is right here, right? So because that is a like the angle is with respect to the y axis, so I would say the x component will be sine, like here, which will be like v12 sine 47 degree, and that is a x component which is I cap, and the y component will be cos, so it will be v12 cos 47 degree. Okay, that is j cap. Now you have this and also they gave us the velocity of the one with respect to the ground, I guess, because we are taking that with respect to the ground. Everything is with respect to the ground because or you can say like with respect to the shore. So that is 0.775, and that is j cap. Okay, so right now all we need to find out the velocity components of the second with respect to ground, like the second boat, because we're looking for the second boat's values. So the second boat's values will be the the x component of the 1 2 and the this one, because when you like do, let me show you here that how we're gonna solve it. So we're looking for the second velocity, right? The respect to ground, this is what we're looking for. And for this part we will do like v21, because I'm going to separating this 2g, and I will include 1 in that. Okay, so v21 plus v1g. So this is like how they will split, but we have like v12 and this one is v21. So then what we will do, we'll take the negative of that, because in the vectors what we can do, the opposite direction can give the same answer. So this is how it will look like every time. Let's say you have instead of this a question right here, I'm giving you another example. So the boat with respect to water, and we have water with respect to ground. Let's say these two like these two velocities as well. So I will add them to get the velocity of the boat with respect to ground, because that will be like boat with respect to water plus water with respect to ground. That is how we always add the velocities to get the relative velocity. Now this is the negative part, like this one is a negative, right? So the negative value is of this one, the whole thing. And I will only use the and y component, like the x component of v12 and y component of v1g. So that will be negative v12, which is v12 sine 47 I cap, plus v1g, which is 0.775 j cap. So this is what we are looking for now. So that will be the component part. And let's say if we calculate like v12 sine 47, this whole value, like how much it will be. Let me solve that on the calculator. Okay, so approximately it was 1.6, and then that is I cap, and I have 0.775 J cap. Now, if we need to find out the magnitude of this velocity, right, that will be the square root of 1.6 and 0.775 square, and then add them to get the final answer. And let me see how much is it. Okay, so that will be 1.76 meter per second, which is the magnitude of the velocity of the second boat with respect to ground. Now if you need to find out the direction, we can use either tan or sine like the sine inverse. So now the direction would be the angle, right, again. And as I mentioned in the previous question, that we will get the tangent of the angle of the two components, and the two components were 0.775, because y upon y upon x, that'll be 0.775, okay, upon 1.6. So this angle will be in the negative form, because this I cap was negative. That means the angle would be theta, which is tan inverse of 0.775 upon 1.6 in the negative form. So the negative value is telling us that the direction would be something like this in the diagram. So let me show you. The direction would be, okay, so the direction would be in this way, because we oppose it, this v12 component, like, right, because that was the negative component. And now you can say the angle is right here. So this is the angle which we're looking for. Or respect to x-axis, or the if they ask you to find out the velocity like the direction respect to east, that will be this angle right here. Okay, so either way the answer will be the positive value along east, and the negative value will be along the this direction. So either I can say like the north of east, right, this direction, and the second one will be the south of west, yeah, south of west. So you will get the answer from this question by solving, by using the calculator.